Welcome to the Archaeology Studio. Today's episode considers scientific models in terms of balancing details with practicalities. A scientific model aims to make sense of the complexities of the world in a more manageable format or framework. Instead of reiterating every detail that exists, a model identifies the most crucial parts of the known universe of data and functional properties. A complete replication of the world would be just as cumbersome and overwhelming as trying to comprehend all of reality all at once. Instead, a model can identify the key aspects of the world or universe and then represent the whole reality in simpler and more manageable practicality. A model of a woodland habitat does not describe every single tree one by one individually. Rather, a model refers to the larger unit of a forest, internally composed of several trees. One popular form of a model is a miniature representation, such as seen in a scaled replica or in a map. At a global scale, a physical map shows the major bodies of water and land masses, but the details are lacking or missing for showing the exact shapes of coastlines and other geographic features. A map may not even include some aspects of the world, such as mountain ranges, forest cover, urban developments, roads, or other categories of information. A map as a model represents the world in terms of some information categories, but not in every aspect. Even if the model shows an information category, such as archaeological site ruins, then the representation could be variable. The simplest representation might show the presence versus absence of archaeological ruins as a binary positive versus negative value. Another representation might show categories of zero, low, medium, or dense site ruins. Yet another representation could show the categories of sites as ancient residential settlements, ritual caves, and other categories. Still another representation at an exceptionally detailed scale of view might show the individual pieces of stonework ruins, distributions of broken artifacts, and other aspects of the environment. The more detailed representations are indistinguishable and ineffective at a distant perspective. Equally important, though, the more rudimentary representations are disappointing and overly simplistic at a closer perspective. A highly detailed representation is impractical and probably unnecessary at the scale of the entire world, but a detailed view potentially is useful for a selected sample area. In this approach, a particular study area or case study can represent the larger world. In archaeology, an investigation at any single site arguably can represent a larger geographic region, an associated time period, or another context or research theme. In this view, the case study acts as a microcosm of the world. In principle, a larger and more diverse study area can incorporate more details and nuance that will be more representative of reality. The core issue still exists here about needing to find a balance between the amount of detail and the practicality of using a model. The size of a study area needs to be large enough to capture a meaningful representation, but it cannot be too large of a size, or else it would create excessive information beyond reasonable practicality. Depending on the purpose of a model, the format can vary in terms of the information categories and the level of detail. In most scientific reporting, multiple maps, illustrations, charts, and other representations of datasets can show the different aspects of a study that in combination can convey the necessary information of the research. I should clarify that a map is only one kind of model. Other models might attempt to make sense of how the world functions in formats such as flowcharts, tree-like branching diagrams, or other representations of complex systems. Game systems mechanics work with the same issues of creating a realistic representation without becoming overly cumbersome in the details, rules, and procedures. Similarly, fantasy world-building settings aim to communicate a sense of a full world without necessarily mentioning every specific point. In any model of how the world works, the key points or components are portrayed as idealized categories of information. A model cannot include every possible category of information, or else it would be repeating all of the details of the world or of the universe. Instead, a model works with selected categories of information as practical representations of the larger reality. Next, within each selected category, the level of detail can be adjusted, again following the principle of seeking a balance between the amount of detail and the practicality of using a model. In concluding this episode, I hope that I have clarified about scientific models in terms of balancing details with practicality. How would you approach these issues and apply these concepts? If you liked this video, then please consider to subscribe to this YouTube channel, share with your friends, and explore more online videos with the Archaeology Studio.